All right, let's do some areas of some other quadrilaterals. All right. So what have we done so far? We did kind of the basic ones, didn't we? Did what was the first one? Rectangle. Triangle. We did triangle and parallelogram. Okay. So we're going to do some more. So what are some other quadrilaterals? A rhombus. Okay. Okay. So yeah, rhombus is one of them. What's another one we don't talk about all that often? A kite. All right. And what's the other one where you got only two parallel sides? Trapezoid. That's what we're going to do first. Okay. So let's do the area. So a lot of these have a lot of things in common, right? Base and height. What has to be true about the base and the height? They're perpendicular to each other. Very good. All right. So there's a lot of similarities on what we're going to do today compared to what we've done before, but a few little differences. All right. But there's definitely similarities. So it's not like all crazy brand new. Well, actually, a couple of them are a little bit crazy. Let's see. Rhombus is a little bit different, and kite definitely is a little different. So trapezoid is kind of the one it's fairly similar to what we've done before. So let's write that down. Trapezoid. Trapezoid has a lot of similarities to something else that we've talked about. Well, it's similar to a square in that they have four sides, okay? But here, let me just do this. Because a lot of people don't even consider these to have similarities. But you're going to see when we do the area of this that there's definitely a similarity. All right? So watch this. What if I took that triangle and I chopped off the top of it? Like that. Everybody see that? All right? Then I took this down to here and this down to here. So that's kind of like a trapezoid, except we chopped off the top. And we didn't just chop it off any old way. We chopped it off so it's parallel to this bottom. Everybody watching? All right. So there's a lot of similarities between trapezoid, which is what we're talking about now, and a triangle. I do this thing in my notes to kind of show you how they got it. To tell you the truth, I think I'm just going to skip that part and I'm just going to show you what the area of the trapezoid is. You'll probably be happy about that. All right. But I do have it in my notes to show you why it is what it is. But what I'm going to explain to you is kind of easy to remember as well. Now remember, the area of a triangle, what was the area of a triangle? It was the base times the height, what? Divided by 2. Okay. Or you could say what? Half the base times the height. Either way, same thing. Do you agree? So remember what I said, the trapezoid is kind of similar to a triangle. So it does have a base, but remember it's got more than just one base. How many bases does a trapezoid have? It's got 2. It's got one down here. We'll call that base 1. It's got one up here. What are we going to call that? Base 2. Very good. All right. And since we're doing area, you got bases. What's the other thing that's really important? The height. So where would the height be? It'd be from here to here. Agree? All right, so that would be the height. So, like I said, it's very, very similar to a triangle. So the area, watch, and it starts with T as well, doesn't it? All right, triangle, trapezoid. So I'm going to, instead of writing T, I'm going to write trap. Okay? So the area of a trapezoid is really, really close to the area of a triangle. Remember, the area of a triangle, I'll just write it up here. I'll put AT. And when it's just a single T, that's triangle. What's the area of a triangle? 1/2 the what? Base times the height. Would you agree? But how many bases does this thing have? It's got 2. So if I would have taken this base and put it right here, okay, what you would do is you'd add up the bases. All right, so the trapezoid, the area of a trapezoid is really, really close to the area of a triangle, but instead of having one base, how many does it have? It's got 2 of them, and what are you going to do with those 2 bases? Add them up, and that's it. So watch, it's 1/2 the two bases added up times the what? Times the height. And that's it. So if you remember that a trapezoid starts with T, triangle starts with T, it's very, very close to the area of a triangle, except what's the big difference between a trapezoid? It's got two bases instead of one. Does that make sense? Yeah. We did this whole thing where I split this into two triangles, okay? What's the area of this? This one is 1/2 base times height, correct? What's this one? This height of this triangle right here is the exact same height as this one, but it's got a different base, correct? So really, you're adding the two together, aren't you? You're finding the triangle here, adding them together, but the height's the same, so really, the only thing different is what? Just adding the two bases. So that's kind of how you got the area of a trapezoid, without going into great detail. We good? All right, yeah. It's not too hard. It's the easiest one. So an example with a trapezoid. So it says find the area of the trapezoid. Find the area of the trapezoid. All right, so they tell you it's a trapezoid. So there's stuff that you know about it. Let's do this. Just kind of make it look like this. That goes to there. That goes to there. And they tell you from here to here is 4.25 inches. So 4¼ inches. And this one down here is 3.25 inches. You know what that little thing right there means, right? That's short for inches, okay? Just making sure. And they tell you the height of the thing is 6 inches. All right, so let's draw that. Now you could draw it a bunch of different places. You could go from here. If you went perpendicular, if you went straight down like everybody likes to say, if you go straight down, you'd have to extend that out, wouldn't you? Or you could go straight down to here to extend that out. Or you could go from here and go straight up. Or you can go from anywhere on this trapezoid. As long as you go perpendicular to the opposite side, then that would be the height. Agreed? And they tell you the height is 6 inches. And they just want you to find the area of it. Super easy. They give you everything you need to know. So let's write down the formula, though. All right, it's always good to write down the formula because it helps us remember it. Okay, the more you write it down, the more it's going to help you remember. So it's kind of like a triangle. So I start off with a half. Instead of base, what am I going to write, though? Base what? Base 1. Well, we'll put the numbers in a second. Base 1 what? Plus base 2 times the height. Now, you just plug everything in because they ask you to find the area. Just plug everything in. Put this 1/2 right there. Add up the two bases. What's that? 4 and 3 is 7. 0.25 plus 0.25 is 0.5. So that's 7.5 times the height, which is 6. And then if you want to use a calculator, you can. But we can make it a little bit easier. Look, you're multiplying all three of these together. So it's 1/2 times 6. What's half of 6? It's a 3. Right? Do you know what that is? 2.5. And that's area. These are all inches, so it's what? Inches squared. If you put the squared, it's kind of weird to put this symbol for inches and then a squared, so we're going to put IN for inches. Just looks a lot better that way. Make sense? Yeah, pretty straightforward. Wouldn't you agree? I think so. Now, sometimes they're going to get a little tricky on you like they did on the last one. Sometimes they're actually going to give you the area and one of these are going to be missing. Okay, either that'll be missing, this will be missing, or this will be missing, and you got to fill it in. You see that? So you're going to have to do a little bit of algebra. Sometimes they're going to give you this area, but one of these three things are going to be missing, and you're going to have to do some math to figure out how to get those. But this example, they made it really straightforward. They just asked you to find the area. But like I said, you know that they could change things around a little bit. All right, let's go to a kite. Everybody go to trapezoid? Yeah, really simple. Very close to triangle. That's why they did it first. Okay, get the easy one out of the way. And these are just a little bit trickier. Yeah. Let's move that about right there. Should be good. So what am I making now? What is this? Say it. Kite. It's a kite. Good. We had a name for these. This was called, remember that was, what was it called? The crossbar? And then this was called the axis of symmetry. I think is what we called it before. On this one for the area, we're just going to call them diagonals, okay? So we got one diagonal, we got a second diagonal. Doesn't matter which one you call one, doesn't matter which one you call two, all right? So this is a kite. And so I'm just going to give you a formula. Again, in my notes, I kind of go through how we got to this formula. If you want to look at my notes later, feel free. But I just thought we'd streamline this today a little bit and just show you what it is. So here's the area of a kite. Remember, these are diagonals. I'll tell you what, let's do this. Let's make these different colors since we're going to deal with the diagonals. So we got a red one. What color do you want? Blue. Okay. Got it. There's American kite right there. Red, white, and blue, right? All right. So we got these diagonals. We could call one diagonal 1. The red one we'll call diagonal 1. The blue one we'll call diagonal 2, however you want to name it. And so here it is. It's very, very simple. Starts off like the trapezoid and the triangle does. So what is that? Starts off with that 1/2. And then watch this. This is really, really easy. Remember, the red one is called diagonal 1. The blue one is a diagonal 2. All you do is multiply the two diagonals together. Okay? So if I know the length of the red one and the length of the blue one, multiply them together and then do what to it? Take half of it. That's it. So you really haven't seen one quite like that before. But there you go. Let's do an example. The example in the book looks, the kite's just tilted a little bit more. I guess we could do that. Control G will group it. Oops. There we go. So the one in the book looks a little bit more like this. And it's not quite as long. Oh, I shouldn't have done that. Yeah, I'll just keep it like that. No biggie. It's close enough. All right. So here's what they do on the example. They tell you this little bit right here is 13. This bit right here is 30. And then these two are split. Remember this crossbar thing? It's split in the middle, so it's bisected. The red one's not bisected, but the blue one is. And oh, I'm sorry. Centimeters. This is important. And this is 115. Now look, if that's 13, is there any way in the world that that's 115? No. So it's not centimeters. What do you think it is? It's millimeters. That's right. Now remember, on a kite, this crossbar thing is bisected. So if that's 115, what's this one right here? That's also 115. And it's in what? Millimeters. So you got to be really careful on this. You can't just throw these numbers into this just yet because the units aren't the same, are they? This is millimeters, this is centimeters. Everything has to be the same units to be able to do this. So I could change one or I could change the other. I think the easiest way to do it is to take millimeters and change it to centimeters. Remember, in the metric system, which we should be adopting, okay, Trump's changing everything in this world. I need to write him a letter and say, look, write an executive order that we're going to change everything to metric system because it's so much easier. I'm telling you, it's like a Band-Aid. It hurts for a second when you rip it off your hand, but then it's so much better. That's what's going to happen. I'm telling you. The whole world, except for us, uses the metric system. It's so easy because look, if you got to figure out how many inches are in a yard, I mean, that's crazy. I mean, you got to go through all this math. If I ask you how many centimeters are in a meter, that's super easy. Every country in the world uses this, and they've been using it for years and years and years. What's that? But what's different? What do you mean? Well, like I just said, you got to know. You got to know there's 12 inches in a foot, and then there's 3 feet in a yard, and there's how many yards? 1,700 and I forget what it is. 1,760. You know, you got to know all these crazy things like cups and teaspoons and quarts and pints. See, there I go. All right, but if you did milliliters and did they have centiliters? I don't know, maybe. Okay, I'm sure they do. But if you had all that stuff in liters, we're used to liters, right? If you go to Wawa, you could buy a 1 liter Pepsi. You know exactly how big that is, don't you? Okay. but the quarts and the pints and all that stuff, I don't even remember that stuff. Okay, and I grew up my whole life with that. Anyway, my point is, I did live in Australia, and when I was in Australia, they were just in the middle, or maybe at the beginning, of changing everything to the metric system. That was 1973 and 4 when I lived in Australia, and they were changing to the metric system. Okay, and we still are not. Anyway, that's my little plug for the metric system. It's so much easier. All you got to do is move a decimal. That's it. You don't have to memorize all these crazy numbers. 5,280 feet in a mile. That's ridiculous. Okay, why memorize those crazy numbers? Okay, you know what I mean? All you got to do is move decimals. All right, Denise. I don't know. If I keep talking like this, there might be. I'm trying to get finished, so let's get finished. Okay, so let's do this. Thanks for pushing me along. I need it sometimes. All right, so watch. 115 millimeters. How do I change that to centimeters? That's it. It's just a power of 10. So what is it? Do you stick a 0 on the end or not? No. It's 115 millimeters. So where do we move it? 11.5 centimeters. So this is what we're going to use. We're not going to use 115. We're going to use 11.5. Wouldn't you agree that's way easier changing it from one to the other, right? From millimeters to centimeters as it would to go from like inches to feet? Absolutely. All right, enough of that. So how do we find the area now? It's 1/2. What? The one diagonal. It doesn't matter which one's 1 or 2. Let's do the red one first. So what's the red one going to be? What's the red diagonal? 43, right, because this is 13 to here, it's 30 to here. The whole thing, is 43. And then, what's the blue one? Remember, it's 11.5. It's 11.5. So 11 and 11 is 22. Half and a half is 1, so it's 23. Yes, go ahead. Watch the video, okay? All right, you plug that into a calculator. You get 494.5. Now, we changed everything to centimeters. So this is in centimeters. This was in centimeters. So what's my answer going to be? Centimeters what? Squared, because it's area. All right, and then there you go. All right? So that's not so hard, is it? Well, we kind of got one more to do. But they do a little bit of that, what'd we call it? What'd you do yesterday on that homework? What do they call that? With the points and stuff? Coordinate, yeah. They're going to do some stuff with some coordinates in a second. But let's do the third one. Third one is a rhombus. Okay, we're going to find the area of a rhombus. Now, if the rhombus was a square, it'd be really easy to do, right? And we've already talked about it. But is Is every rhombus a square? No. So let me try my best to draw a rhombus here. So what's true about a rhombus? It's a parallelogram, but a parallelogram with all what? Equal angles? Equal sides, right. Because look, now the opposite angles would be equal, right? But not every angle is equal on there. But you do have equal what? Sides. So that's a rhombus. Again, there's a way to, and I did take a lot of time to put this in my notes, but I'm just going to show it to you. And what's nice about the area of a rhombus, it's basically, it's not the same, but it's kind of the same as the area of a kite. So the area of a rhombus, again, is 1/2. But in this situation, we're going to go, hold on, let me take a peek at this. Yeah, it is the same as a kite. I mislabeled it in my notes, and then I put a little note in red next to it so I would remember. So I'm glad I did that. Let's do this. Let's draw some diagonals in here. And we'll use the same colors as we did on the other one. So there's a diagonal. Okay, and let's draw another diagonal. Hit the same color system here. Go blue. There we go. So we'll call the red one D1 for diagonal 1. We'll call the blue one D2. Again, it does not make any difference. So, what's that again? You are? Good. So what is it going to be? D1 times D2. Same formula as what the kite is. All right, so that's always nice. Would you agree? Yeah. Now, what else do we know that happens inside here when we draw the diagonals? Now, it's a parallelogram, so they will bisect each other, so we know that. But something specific, this being a rhombus, doesn't happen with every parallelogram. Do you remember? We studied this. Look at that angle that it forms right here. What does it just look like to you? Looks perpendicular, doesn't it? Okay, looks like a right angle, and it is, right? We learned in another chapter, chapter 5, 6. Was it 6? That was the last chapter you did? Yeah, it was chapter 6. We did this, okay? So we talked about this right here. So that's a right angle. So there you go. There's your formula. You ready for an example question? We'll just use the same picture. And now this time they're not going to ask you for the area. They're going to ask you, remember I said earlier, they could ask you for one of the other things. All right, that's exactly what they're going to do here. So let's make that 3. Let's make this 4. Let's make that 5. Okay, yep, that's good. All right, here's the information. And, or no, maybe I do. Yeah, I do ask you. Hold on, what am I asking? Find the height. Oh, okay. Sorry. If I could just read what I wrote down. Find the height of the rhombus. Find, we'll just put H. Now look at this. This doesn't even have the height in the formula. So how am I going to do that? Well, let's do this. Let's go green. So where is the height? It would be from here to here. You could do it that way, couldn't you? Would you agree? So that would be the height. Or you could go like this. Well, we're going to find the area of the rhombus first. Once we find the area, then we're going to get the height. So watch. Oops. There we go. So this would be the height. That's what we're trying to find. We're trying to find that green one right there. Everybody good? So how would I find the height? Give me a second. Oh, okay. I see what we did. Had to check for a second because this is a little bit tricky. So, if I wanted to find the height, you could look at it as a triangle right here, but you don't know that length of that side, and there's really no way you can find the length of that little dotted line right there. So that's not what you're going to do. But remember, a rhombus is also a parallelogram, isn't it? Do you remember what the formula for a parallelogram was? It was just the base times the height. Okay? So do I know the base of this parallelogram? What is it? 5. Good. So the base of this parallelogram is 5. The only problem is I don't know what? I don't know the height, but if I could find the area, everybody watching and thinking, if I could find the area of this whole thing, let's call it a parallelogram. It's both, right? A rhombus is a parallelogram, but let's call it a parallelogram for right now. So this right here, if I can find the area of that, then I've got this, don't I? I know 5 is the base, right? And then I can solve for h. So what's the problem? What's the deal? What do I need to find? I need to find the area of this thing. Now, it's not just any old parallelogram, okay? It's a what? It's a rhombus. And they gave me enough information to find the area of this rhombus. So that's what you got to do. You got to think ahead a little bit. And you're like, okay, if I got to find this, how am I going to find that? Well, I need an equation that's got h in it, right? Well, I've got a triangle, but there's no way I can find that little bit right there to find the area of a triangle. But I do know this is a parallelogram. So if I just find the area of that whole parallelogram, that would be this one, then that equals the base, which is this, times the height. Then I got 2 things that I know and 1 thing that I don't know, and I can solve for it. All right, so let's do it. Let's find the area of this parallelogram, or more specifically, what? Rhombus. So let's find the area of the rhombus. That's why we're going to find the area of the rhombus. Okay, so I can find the area, so I can find the height. So what is it? It's 1/2 d1 d2. So what's my d1 all the way to there? Is it 4? It's 8, right? Because it's being bisected. So if that's 4, that's 4. The whole thing is 8 times the other diagonal. This diagonal. What's that? That's 6, right? Because if that's 3, that's 3 because it's being bisected. So what is that? 8 times 6 is 48. Half of 48 is 24. So that's the area of this whole thing right here. Remember this formula? Let's use it now. So what's the area of a parallelogram? It's the base times the height. So let's put the stuff in here. What do I know? I know the area now, don't I? Just found it, right? Because I knew the diagonal. So I could find the area of this whole thing. So what is the area? It's 24 equals the base. Do I know the base of this right here? Sure, it's 5. So I put a 5. Do I know the height? Nope, that's what you're trying to find. And so what do I do here? I find the height. Simple algebra, divide both sides by 5. And then h is it's 4.8 if you do the math on it. So that's the h. Now this is, I didn't give you units at all, did I? Everything's in meters, okay? So meters, everything is. I don't have to change anything. So what's the height? 4.8 what? Meters. What was the area? 24 what? Meters squared. Okay? And there you go. You found the height. So that one was definitely trickier than the other ones. The other ones were really straightforward. Hardly had to think about it. You just plugged it into a formula, worked it out. But this one you had to think a little bit, myself included. We good? All right. Got one more example. This one, what do we call that again? the coordinates, right? Yeah, so I'm going to copy that, and let's drag this down here. Yes, right of pass. Oops. There we go. Nice and big. All right, that's good enough. All right, here's what they do. They give you some letters, and we want to find the area of this quadrilateral. Now, they tell you it's a quadrilateral, and they tell you the 4 points. That's all they tell you are the 4 points, and we got to find the area of it. So they use W, they use X, Y, and Z. Okay, and then they give you points for all of those. Yep. All right, so W is 4, 1. 4, 1. X is 1, -3. Y is -2, 1. Oh, it's going to be kind of small. Wonder if we can double it. Nah, 1, 5. I don't think I have 10. How many do I go up? 1, 2, 3, 4, 5, 6, 7, 8. I was going to double it just to make it a little bit bigger, but just going to have to deal with it. All right, 4, 1. So where's 4, 1? 1, 2, 3, 4. Is that 1, 2, 3, 4? There you go. So that's W. 1, -3. 1, 2, 3. That's X. -2, 1. -2, 1. Forgot to put a parentheses right there. And then 1, 5. 1, 1, 2, 3, 4, 5. There we go. All right, so let's connect them and let's see what we got. Now, we want to try to not make any assumptions about this. It's very easy to, but we're going to try our best. All right, and I guess I should put these. So 4, 1, so this is W. 1, -3, this is X. -2, 1 is Y, and this would be Z. Okay, so now looking at this thing, we got to figure out what formula are we going to use. What kind of quadrilateral is this thing? Would you agree? Well, what would we do? Let's do this. You're going to have to do 4 things anyway, so you might as well do this. Let's just do the distance formula, okay, and find the lengths of the lines. Because what does it look like? If I graph this, and I graphed it pretty accurately, okay? I use graph paper and all that. All right, I graphed it pretty accurately. What does it look like? Just eyeballing it. What does it look like it possibly is? Say it, I don't hear. Rhombus, okay. So I got this fan on this computer blowing, and I got next doors all loud, and you're whispering, so I can't tell. Sure looks like a rhombus. Let's see for sure if it's, well, we didn't have a diamond, okay? Diamond was never one of our things, okay? It doesn't look like a kite, though. These two look like they're equal, but it looks like these two are equal as well. And it looks like that's equal to that, doesn't it? It looks like it, just off the top of my head. So let's not just go off the top of our head. Let's actually see if they are equal to each other. So let's do it. YZ. So here's YZ. Can you do distance formula kind of quick now? We just did it yesterday, right? So it should be fresh in your mind. All right, so YZ, these two right here. So what do we do? -2 minus 1, and then 1 minus 5. Let's do a little bit in our head here. This is -3. -3 squared is 9. This is -4, right? -4 squared is 16. Square root, that's a square root of 25. What's the square root of 25? It's 5. So the length of that is 5. Let's just do that a few more times. You okay with that? It's not too hard, is it? I'm just going to remove this just to give myself a little bit more room. Let's drop that down so I can see that number. All right, let's do this one. ZW. Where's ZW? That's that top one and the bottom one. So let's do that. So, all right, so ZW, the top one and the bottom one. Subtract. Let's just do it in our head. Let's do the subtraction in our head instead of writing it down. You think we can? 4 minus 1 is 3. And then 1 minus 5 is -4. Yeah? That's what? 9. That's 16. Same exact thing, isn't it? So what's this? That's 5. You with me? So if you know the distance formula, it's not hard to do. Okay, let's do yx. Okay, these two in the middle right here. So square root, subtract 1 minus -2 is 3 squared. And then -3 minus 1 is -2 squared. So what's -2 squared? Wait, did I do that right? Oh, you know what? I'm dumb. Oh, goodness. Well, no, I'm not that dumb, I guess. Well, let's see. What am I doing? I'm doing XY, right? I stuck wrong numbers in here, didn't I? I skipped to another thing. That's why. All right, so what's this? This is 3. This is -3 minus 1, which is -4. And 4 squared is 16. There's my 9 and 16 again. So that's 5. Guess what? Do it again. That's 5. All right. So now, what is that thing? What do I know that is? I know it's a rhombus, correct? All 4 sides are equal. So let's do this. So how do I find the area of a rhombus? Find the what? The diagonals. Now, if you did this on graph paper, you really don't have to do any math. We could just count. So, by the way, what is the area of a rhombus? What's the formula for it? It's half what? D1, D2, correct? So, look at this. They made it kind of easy for you because you could put the distance in here, find the distance of ZX, right? This one and this one. But you could just count if you did it on graph paper, couldn't you? What is it? 1, 2, 3, 4, 5, 6, 7, 8. Because up here, I'm at 5. Down here, I'm at -3, right? So 5 plus the other 3 is what? It's 8. So one diagonal is what? 8. What's the other diagonal? So again, I'm over here at where? Y is at -2. W is at 4. So from -2 to 4 is how far? It's 6. So the other diagonal is 6. So the whole thing I did with all the sides is just to make sure that I had a rhombus, okay? Might have been off a little bit, right? Just me looking. So I needed to make sure that it was a rhombus, and it definitely is. All 4 sides are equal. Now I know how to find the area of it because I can do the diagonals. The distance between here is 8. This is 6. So how do I find the area of it? It's 1/2 times what? 8 times 6. And we did that one already. That's 24. And I didn't say the units. Yep, they never say the units. So I'm just going to write units, what? Squared. And there you go. So that's the area of this whole entire rhombus. Got it? Okay. Yeah, this coordinate stuff's starting to get a little easier now, and you can see why it's very helpful to know how to do that point stuff, how to find distance, how to find slope, and all that kind of thing. All right. Now, this is also a parallelogram. You could find the slope of this and this, see that they're equal. Find the slope of this one and this one, see that they're equal. All right. It's a bunch of things you could do with this. But that's what we did because we wanted to find the area. So we took the diagonals, find the length of the diagonals, multiply them together, took half of it, bam, you got your answer. We good? All right. So your homework, I believe, is 1 to 14. Is that what I said on the lesson plans? So it's 1 to 14, section 7-2. There's no A or B. Well, I don't think. Did I put A or B on this? Yeah, I did actually. So this is A. So I'm going to split it up. So probably on Monday, we'll go over this and I'll just have you work on part B in class. Is that okay? There you go. Well, just go to 7.2. Just go to section 7.2. You see where the problems are, right? Just do 1 to 14. It's 308, 309. Page 308, 309. Everybody cool? All right. Enjoy your weekend. See you on Monday.